Hey guys, Travis Gillespie here. In this next video, we're asked to solve this multi-step equation here. So let's get started. I'm going to combine like terms first. I have 3p plus 5p, which will give me a value of 8p plus 4, I'm bringing everything else down, is equal to 20. So now from here, it's just a matter of isolating the variable p. So my first step, I'm going to subtract 4 from this side of the equation. If I do it to this side, I'm going to do it to the other side. Now before I move forward, I just want to make a note. Some people might be saying, well, why didn't we divide by 8 first? You can divide by 8 first, but you have to do it to every term in this equation. So it might be a little bit trickier to do. So the thing that I tell students is just to think about running through PEMDAS backwards. Run the order of operations backwards when trying to isolate a variable. So I'm going to subtract 4 on both sides first. Alright, addition of 4, subtraction of 4, cancel out. I'm left with 8p is equal to 20 minus 4 is 16. Now from here what I'm going to do is I'm going to do the inverse operation of multiplication. So I'm going to divide by 8 on both sides of the equation. Multiplication of 8, division of 8 cancel out. I'm not left with 0, I'm left with 1. So I'm going to bring p down. I'm hiding the 1. It's equal to 16 divided by 8 is 2. From here I'm going to substitute 2 back into the original equation. So I have 3 times 2 plus 5 times 2 plus 4 is equal to 20. 3 times 2 is 6. 5 times 2 is 10. I'm going to bring down these addition symbols. I'm going to bring the 4 down. It's equal to 20. Alright, so 6 plus 10 is 16, plus 4 is 20. Let's bring that information down. 20 is equal to 20. That checks out. So my solution is p equals 2, and let's box it up. Cool, let's take a look at another problem. Okay, in this equation, I want to combine like terms first, but I'm going to use my highlighter to highlight those like terms. I have 11d, I'm just going to make that a little bit darker. 11d, but that's a positive 11d. I know it's positive because the operation on the left, it's hiding, so I'm going to think of it as a little addition symbol. So if I wanted to, I could just make a little note that that's a positive 11d. And I'm also going to highlight this subtraction symbol with d over here. So I have 1 or negative 1d over here. Now negative 4 or minus 4, that's a separate term. Let's combine the like terms. So positive 11 take away 1 will give me a value of 10. So I have 10d, I'm going to bring down 4. Subtraction of 4 is equal to 36. Alright, I'm going to run through the order of operations backwards to isolate the variable d. So I'm going to add 4 to both sides first. So add 4, add 4. Now subtraction of 4, addition of 4 cancel out. I'm left with 10d is equal to 36 plus 4 is 40. So I'm going to divide both sides by 10. Now both 10s here, a multiplication of 10, division of 10 cancel out. I'm left with d is equal to 40 divided by 10 is 4. I'm going to take 4 and substitute it back into the original equation. So we have 11 times 4. Let's fix that 4. Okay, and I'm going to subtract 4. And in fact, I want to use green for that. Minus 4 minus d, or 4 in this case. And that should be equal to 36. But we're not sure, so let's see if this stuff is equal to this stuff. So 11 times 4 is 44. I'm going to subtract 4 and subtract 4. and we're going to see if this is equal to 36 still. So 44 minus 4 will give a value of 40. I'm going to subtract 4, see if it's still equal to this stuff. 40 minus 4 is 36, and 36 checks out with 36. Therefore, in the long run, 4 is a solution for D. And I can box this information up. I'll see you in another video.